Welcome to a lesson with Dr. Powell. Let's take a look at the graphs of logarithms. So perhaps we have something like log base 2 of x. What would this look like? Well, it's the inverse function of 2 to the x. Now the graph of 2 to the x looks something like this. Multiplication slope of 2 and a y-intercept of 1. Now, if you go to the graph of the inverse, all you do is you swap your x's and y's. Your x's and y's swap places. So we can draw a dotted line at y equals x. And then we think, okay, this point right here is a 0, 1. So if we swap x's and y's, we're going to get a 1, 0. Now, you see how we have a asymptote of y equals 0? For the logarithm, that'll turn into an asymptote of x equals 0, since we're swapping our x's and y's. And we can get a point for 2 to the x. If we plug in 1, we're at 2. So for the logarithm, when we plug in 2, we're going to get up to 1. So naturally we get our graph. It's just an exponential on its side. So that's all a graph of a logarithm is. It's an exponential on its side. We can do transformations with these. For instance, if we have log base 5 of x plus 3, and maybe we have minus 2, let's look at the graph of this. First, let's look at the graph of y equals log base 5 of x. Now, it's just an exponential on its side. 5 to the x goes up like this, and notice the 5 to the x, the y-intercept is 1. So we have a 1 right here. Also, when we plug in 0, we get 1. So now all we do is we just flip it over and notice that it has the same basic format. All logarithm base graphs like this, no matter what the base is, always have this asymptote right here. Just like all exponentials have this asymptote over here. Also, all logarithms are like this, come from something with a 1 right here, so that they have an x-intercept of 1. So when you plug 1 in, you should get 0. Log base 5 of 1 is 0, which should make sense. 5 to the 0 is equal to 1. 0 is the exponent that's extracted when you put in 1. So then it just comes up like this. So that's the graph of log base 5 of x. Then here, this just means that we've moved all our x values down by 3. So that means the asymptote is moved, and we'll draw this over here. The asymptote is moved to -3. And then the minus 2 just means we've shifted it down. So instead of coming up to 1 there, we've shifted it down so that it's at -2 when we come to that point right there. So then it just looks something like that. And there's our graph. Thanks for watching.